Hello and welcome back to the channel for episode 5 in the linear series. My name is Professor Adjovan and today we're going to be talking about compound inequalities. So what do the problems look like? Well, you have three examples, the three examples that we're going to be doing in this video that are on your screen now. So if whatever you're working through, whether it be homework problems or something else, if they look like these problems, this is the correct video for you. So we're going to be solving these problems and then we're going to be graphing our solutions. So before we get into what the compound word in this case is and, means and how that's going to change our answer, we're going to approach this as if this was two separate problems and solve them individually. So looking at the inequality on the left, we want to solve these just like we have in the past couple of videos, where we want to isolate the x. To isolate the x, we want to subtract 5 to move it across the inequality, where we have 2x left on the left side of the inequality is greater than, and negative 3 minus 5 is negative 8. Now we want to get rid of the 2 in front of the x. We do that by dividing it across. So we're left with x is greater than negative 4. And going to the inequality on the right, we want to isolate the x again. So we want to subtract the 7 across. So 4x is less than 8. And to get rid of the 4 in front of the x, we need to do the opposite, right? It's multiplication. So we divide by 4, leaving us with x is less than 2. Alright, so what do we do from here? Well, we need to graph them. We want to graph both of our solutions on the same number line. So looking at the left solution where we have x is greater than negative 4, if I put negative 4 on the number line, it's greater than, not greater than or equal to, so I'm going to put an open circle, right? And greater than means I have all of the numbers to the right. For the other solution, we have when x is less than 2. So we're going to put 2 on our number line, right? And 2 is bigger than negative 4, so it's to the right of that point. And again, it's less than. It's not less than or equal to, so we're going to put an open circle. And it's everything less than 2. Right, so I'm going to draw an arrow all the way to the left. So now we get to look at the new thing, the compound word. So this is an and. So I want to look at where is this true for both, meaning where are my values both greater than negative 4 and less than positive 2. So what I'm looking at graphically is where do the two solutions overlap. So the red and the blue overlap right here in the center between these two open circle points. So my final solution is going to be in green from negative 4 over to positive 2. All right, this value in the middle. All right, so and is where they overlap. All right, and our final solution is that single line. Well, what about an or? Right, there's two compound words that we could see in these types of problems, and or. So we just did an and, let's do an or. Again, we're going to approach it just like we've done in the past couple of videos, solving these normally, solving them as if they were two separate problems. So in order to do that with this 2x plus 1 is less than negative 3, we're going to move the 1 by subtracting it. So we have 2x is less than negative 4. And to get just the x by itself, we divide by the coefficient, leaving us with x is less than negative 2. And with the inequality on the right, we want to get the x's by itself, so we subtract 2 from both sides, giving us 3x is greater than 3. And then we divide both sides by the coefficient, leaving us with x is greater than 1. Again, I'm going to make a number line. And I'm going to start with my inequality on the left, negative 2. We're going to put that there. It is a less than, not less than or equal to, so I'm going to have an open circle, and it's everything less than this value to the left. Now I want to graph my other solution when x is greater than 1, so I'm going to put 1 on my number line. 1 is greater than negative 2, so it's to the right of it. Again, this is greater than, not greater than or equal to, so I have an open circle rather than a closed circle. And greater than means all of the values to the right. So my final answer is going to be OR. Where is this true? Where can my x values be when x is less than negative 2 or greater than 1? So what I'm looking for is where both solutions are true. So my final answer is going to be where both of these are true, or where either or, I should say, are true. Meaning we can have both this solution where x is less than negative 2 and the solution where x is greater than 1. Alright, so where and was where they overlap, or is where either one exists. Let's look at a third and final example, another OR statement. Alright, so we're going to start exactly like we have been, isolating the x. So I subtract 1 from both sides, leaving me with negative x is greater than negative 3. And then I need to get rid of this negative in front of the x, and we do that by dividing by negative 1. And we know that when we divide or multiply by a negative number, that this inequality sign needs to change. It needs to change from greater than to less than. So we have x is less than positive 3. With the inequality on the right, I want to distribute the number in front of the parentheses. So we have 12x minus 18 is greater than or equal to negative 6. Then we can add 18 to both sides, leaving us with 12x is greater than or equal to positive 12. And we divide by the coefficient in front of the x. So we have x is greater than or equal to 1. Again, we make our number line. Starting with the one on the left, x is less than 3. I'm going to put that 3. It's less than, not less than or equal to, so we're going to have an open circle, and it's everything to the left. My other solution, x is greater than or equal to 1, I'm going to put that on the number line, and 1 is less than 3, so this point is going to be to the left of 3. It is greater than or equal to, so we're going to have a closed circle. And it's everything greater than, so I'm going to be to the right of this point. Now, this is OR, so this is where either function is true. So it could be over here all the way to the left. It could be here in the middle, or it could be over here on the right. So in this case, because the functions kind of overlap and they extend all the way to the left and all the way to the right, and this is an OR compound inequality, our solution set is everything. It is the entire number line. Alright, that is it for this video on the compound inequalities in the linear series. If you found this video helpful at all, please consider giving it a like and subscribing. It really means a lot to me. Thanks, good luck, and we'll see you in the next one.